Music has been a part of many cultures for thousands of years and remains a part of our daily lives. It permeates the radio, fills the crucial role of setting the mood in theatrical productions of all kinds, and is found in the background of most advertisements to put the viewer in a feel-good mood. It's apparent that music invokes emotions in the listener, but to learn more about how and why this happens psychologically, we need to break music into pitch and rhythm. A single pitch has little meaning, but when paired with another pitch, it forms an interval, which is much more relevant to psychological analysis. Pitches, or intervals, are then strung together to form melodies, the dominating line in a piece of music. There are many facets in the ongoing investigations of the psychological effects and influence of music. Many studies investigate the emotional effects of melodic stimuli. Others analyze and catalog overarching melodic tendencies, and still others observe how these tendencies affect our expectations in a melody's resolution. I will lay out some of these facets plainly. There are many reasons for people to listen to music. The most prominent of these is to express and experience emotions not easily put into words. As I stated earlier, a melody is a series of pitches which are relayed by interval, so it's going to be relevant to observe how intervals interact within the spectrum of human emotions. In a 2000 study by Marco Costa, a number of participants were played intervals and asked to rate the intervals among 60 adjectives, 30 pairs of bipolar adjectives. Analysis of these observations showed that intervals were interpreted as being more negative in the lower frequency ranges than in higher frequency ranges. Intervals were judged more unstable and vigorous in the higher registers than in the lower registers. Analysis aside, this raw data could be extremely useful. It gives data on where these intervals fall within these 30 pairs of adjectives, and the information that was gathered will be valuable in the pursuit of creating melodies tailored to an individual's emotional experiences. There's a recent field that would find this information very useful: emotion recognition in music. In a 2000 endeavor from the Department of Electrical and Computer Engineering from Drexel University and the Computer Science Department from Ithaca College attempted to combine audio and lyrical analysis into a comprehensive analyzer to catalog emotions expressed in a piece of music. It was mildly successful, but it's a developing field. Now, the influences of classical music on our expectations of the resolution of a melodic line is obvious as well. In a 1989 study by Voss and Troost, where a broad spectrum of classical pieces were indexed on frequency of descending and ascending intervals and whether those intervals moved to adjacent notes or jumped across several notes, it was found that smaller intervals were ascending while larger intervals were descending. A nice example of this can be found in Beethoven's Minuet, which I will play. The D jumped down to the G and then ascended up again and then back down. In another study by Schellenberg in 1994, it was found that when subjects were played a partial melody and asked to suggest a final note, ascending resolutions were more commonly went to an adjacent note, while descending resolutions jumped a few notes. The interdisciplinary study involving music, psychology, and neuroscience is a lively one that has a great deal of potential. The studies outlined in this paper are only 4 of many hundreds. Given the constantly evolving technology of today, we can expect technology to develop a personalized melody and mood articulated to an individual within the next decade or two.